Hello everybody, welcome to Chapter 6.1, Part 3, Recurring Decimals. One may ask, what is a recurring decimal? Well, a recurring decimal is when a number repeats itself after the decimal point forever and ever and ever. In this case, here it's 0.33333333333, and this will go on forever. But a shorthand way of writing it is to have the 3 and put a bar over it. And if you see a bar over the 3, that means the 3 is the part that's repeating itself. Here we have 0.24, 0.24, 0.24, 0.24. And again, we use the line to show the part of the decimal that's repeating. In this case, it is 24. So we have 0.24 with a bar over the 24. In this case, we have 0.714, 714, 714, 714, 714 over and over and over again after the decimal point. So we can write 0.714 with the bar over it because it's the 714 that's repeating itself. It turns out that these recurring decimals actually form fractions. And so what we're going to do is we're going to find what is essentially the fractional equivalent of these recurring decimals. So for example, 0.33333, which is also 0.3 bar, is actually, as a fraction, 1/3. In example number 6, we're asked to change 0.8 bar into a fraction. And remember, 0.8 bar means 0.888888888 forever and ever and ever. So if we go over to the whiteboard, we'll see how to work this one out. .8 bar, so we're talking about, which is the same thing as 0.8888, and the ... means it goes on forever, and we want to change that into a fraction. So how do we do this? Well, we want to be able to subtract off all this repeating stuff, and that's the idea. So what we're going to do is we're going to multiply this by 10. So 10x, we're going to say, is equal to 8.8888 ... And then we're going to say x, and we're going to let x be our original. So that's going to be 0.88888 ... And now what we're going to do is we're going to subtract the two. And the trick here is that by subtracting this from this, we're going to get rid of these 0.88888, all that recurring stuff, and we're going to be just left with a nice whole number. So here we have 10 minus 10x minus x will leave us with 9x, and there we have, and then it's going to be 8 minus all that, and when we subtract, this is going to go away, and we're left with 8, and then as when we usually solve for x, divide by 9, and this will imply x is equal to 8 over 9. Now, of course, you would want to maybe check this. Let's see if I was to do it on my calculator here. And I have my calculator here, and I'll just clear what I had before. And I go 8 divided by 9 equals. So there I have my 8 divided by 9. And let's see if I get back that original decimal, and indeed I do. So indeed now we know by that check that indeed that is correct.
Reviewing how we converted 0.888888 or 0.8 bar into a fraction, we let x equal 0.88888. Now we wanted to get rid of all the recurring stuff. So only one number is recurring, so we multiply by 10. And that means we get 10x is equal to 8.888888, going on forever. Then what we do is we subtract our x, which was equal to 0.88888, and we get 9x is equal to 8, because when we subtracted all this, it ended up disappearing. And now we have x is equal to 8 over 9. Now, if we use a calculator and we plug in 8 divided by 9, we should get back, and we will get back, 0.8888. So therefore, 0.88888 going on forever is equal to 8 over 9. In example number 7, we're asked to change 0.79 into a fraction. Now, of course, 0.79 has a bar over it, so it's 0.79797979 going on and on and on forever. Let us go over to the whiteboard and see how we would deal with a situation where the decimal is repeating two numbers.
Now, in example number 7, we have something where we have actually two parts are repeating, meaning the 7 and the 9 repeats itself. So that means that we have, this will be equal to 0.797979, ... So we want to be able to turn this one into a fraction. But how do we do this? Well, again, we want to be able to clear this out and bring a decimal over there, and we want to subtract off the repeating part. So in order, since this is in the hundredths place, this decimal point, we're going to make 100x equal to 79.797979, etc. So now we have that repeating part, and then what we're going to take is our original part, because we want to line it up exactly. So we have our original x, and it's going to be 0.797979. And you want to make sure that when you line up the decimal, the repeating is exactly the same. You don't want to have different repeating. You don't want to have one that says 797979 and the other one that says 979797. It will not work. You want to make sure this and this are exactly the same. And then you subtract off. So then you subtract, and you end up with 99x is equal to 79, and then you divide as usual to solve for x. And this is your final x, and then let's go check it to see if we get back our 79 over 79 over 79, and I'm going to do that right now on my calculator. So let's see, we have 79 divided by 99, and what do we get back? Equals, and there it is. So I'll do it again so you could see better. So we have 79 divided by 99, and then we equals, and there we have our original back, and that's what should happen. So indeed, this is correct. So it's always a good idea after you do this is to check to see if you get back your original decimal.
Reviewing example number 7, we let x equal 0.79797979, etc., 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 because we have the bar over it, and that means the 7, 9 is repeating. Notice that the bar is over the 7 and the 9. Two numbers are recurring, so we have to multiply it by 100. So 100x is equal to 79.797979. Note how this begins with the 7, not the 9, in the same order as we have here. And that is very important that you maintain the same order. Otherwise, when you subtract, it will not disappear. So now we subtract the x from 79.7979, and we subtract 0.797979, so that means this part will go away, and it leaves us with 100 minus 1, which is 99x, is equal to 79. And we divide both sides by 99 in order to get 79 over 99. This, again, can be checked with a calculator. 79 divided by 99, we will get this back as a repeated decimal. So 0.79797979, etc. is equal to 79 over 99. In example number 8, we have to change 0.13636636 into a fraction. Now notice only how the 3/6 part is repeated. The 1 is not repeated. So let us go over to the whiteboard and see how we would do a situation where it is mixed, meaning some numbers are repeated and some numbers are not.
Now, example number 8 is a little bit trickier because only part of the number is recurring. So we have 1.36, but only the 3/6 part is recurring. So that means what this is equal to is 0.1363636, but we have this 1 here that gives us a little bit of a problem. So what do we have to do to clear it? Well, I'm going to have to bring this decimal point over here to clear it. And we look at it, so we have the tenths, the hundredths, and the thousandths place. So that means we're going to have to multiply this by 1000x. That'll give me 136.363636. And now I want to clear the 3/6 part. So in order to do that, I want to make sure that I go over here. So the next thing I have to clear is this, so I can have the repeating 3/6. And since this is the tenths place, I'm going to multiply that. 10x is equal to 1.363636, ... And if you notice, and I'll make that very, very clear so there's no misunderstanding, notice how my 3/6, this is exactly the same. The 3/6 on top after the decimal point and the 3/6 on bottom after the decimal point is exactly the same, which means that I can subtract it or easily subtract it off. So that when I subtract it off, so now 1000 minus 1000x minus 10x will give me 990x. So I have that. And then I subtract off 136. All this will go away. So it's 136 minus 1. So I have 135. And then I continue 990 divided by 990. And of course, if you like, you notice that we can reduce this. So if you want to reduce it, it turns out that when we reduce it, it's 3/22. And the thing is that you want to check it to see, well, am I going to get this number, this recurring decimal back again? So here I'll take out my calculator again, and I'll clear it. And so I have 3 divided by 22. So you see I have 3 divided by 22, and it's equal to, and there is my number, 0.1363636. So that tells me that indeed it is correct. Now, if you don't believe my reduction, let's do the 135 over 999. So here I do let's do this, 135 divided by 9990, and there, and here it is back again, just like as is supposed to be.
Reviewing number 8, we let x equal 0.136 and we multiplied that by 10, so we got 10x is equal to 1.36 bar because we want to isolate the recurring part. Then we want to subtract that from something. We multiplied x times 1000 in order to get, again, a recurring part that we can subtract for. So when we multiplied it by 1000, we got 136.363636, etc. Now we have both of these, this one, the 10x, and the 1000x, with the same recurring decimal after it. That puts us in the position of being able to subtract off the recurring part. And we ended up with 999x is equal to 135. And of course we divided x is equal to 135 over 990. And then we simplified, and I got, when I simplified, 3 over 22. And I checked with my calculator, and I saw that indeed I got this decimal back again. So 0.136363636 forever equals 3 over 22. In example number 9, I'm asked to change 2.3713 into a fraction. In this case, instead of starting with a 0, I'm starting with a regular number. So let us see how we deal with a situation like this on the whiteboard.
What about 2.3713? And the 13 is the recursive part, because let's say you don't have a 0 here. So what do? Well, that's the same thing as saying 2.37131313. So that means the 13 is repeating itself, but this part is not repeating. So we want to figure out, what do we multiply it by? Well, we have to go all the way, we have to clear the first decimal all the way here, because we have to clear this, and then we have to make sure we include all the recursiveness. The recursiveness. So we have here, so that'll be 10,000, because here's the 10,000th place. 10,000x is equal to 23713, or 23,713. And then we want to make sure, and then we want to go, the next point we want to do is go clear here where we start off the repeating part. So we start off the repeating part at the hundredths place. So that means that this is going to be 100x is equal to 237, and I forgot the point there with 3, 3, 3, 3, and then, okay, and this point 3, 3, 3, 3, and we do the same process. Remember writing all that, okay, and we do the same process, so we end up with 9,900. X is equal to 23,476,476. And then, of course, to solve for X, we divide in our usual way. And so this becomes our X. So there's our fraction. Now, of course, because of the craziness of this one, we want to check it. And let's see if indeed it did work. So I have my calculator here, clear. And I have 2, 3, 4, 7, 6 divided by 9900 equals. And there is my number back again. So here, as you see here, and on my calculator, I got back my number again. So even though, this is a technique that works all the time in changing decimals where they are repeating.
Reviewing what we just did on the whiteboard, we let X equal 2.3713131313, etc., and we multiplied this by 100. We did this in order to isolate the recurring part of the decimal. So we got 100x is equal to 237.131313. But we want to subtract this from another, so we multiply our original number by 10,000. And we get 10,000x is equal to 23,713.13131313. We did this in order to make the number with the recurring part, meaning the part after the decimal, the same. Now we are in the position that we can subtract. So we have 10,000x is equal to 23,713.131313. Minus 100x is equal to 237.131313, and we end up with 9,900x is equal to 23,476, and we divide by 9,900, and we get x is equal to 23,476 divided by 9,900. And then I checked on the calculator and saw that indeed, after I did the division, I got this number back. Thank you very much. I hope you enjoyed this video. Be well, take care, and goodbye until the next time.